So today we're on College Algebra 2.5 and we're just working through some parent functions. Sometimes I call them mother functions because that's just fun to say. And so we're going to identify parent functions, transformations, and then we're going to graph it. So as I look at this first one, I start and I see this right there. So what is my mother function? So I'm always going to write down my mother function is an x squared. And hopefully, if I was right in front of you, I'd say make an x squared for me. And hopefully you would kind of make that with your arms. So the basic mother function of this is an x squared. I know it's going to be a u. Now, after that, I can go through and I can just kind of figure out what are some important points. Well, I look right here. I know that the whole thing is going to shift right 5 and up 3. No, not up 3, down 3. So right 5, down 3. So I'm just going to make a quick note of that. Shift right 5 and down 3. So remember that the x movements, I always kind of do the opposite of what you think, and y's just do what they're supposed to. So really what happens in this, because it's a mother function of an x squared, that actually just tells me my vertex. So my vertex is going to be at 5, -3. So I'm just going to graph that point. So 1, 2, 3, 4, 5, down 3, 1, 2. That's right here. Okay. Did anything reflect? No. Did anything, like, did it get taller or wider, anything like that? No. So just from a basic mother function, and if you're struggling with that, make sure to go back and look at the previous page of these notes. What I know about an x squared is that from the vertex, if I go 1 to the right, well, 1 squared is 1, so there's a new point. And the other nice thing that I know from a long time ago, that there's this axis of symmetry right here. So if I have this one right here, then there's going to be one right across. So if I went -1, then I would go up 1 as well. Now given I shifted all of this, so I am now counting from the vertex. So now if I went over 2, 2 squared would be 4, so up 1, 2, 3, 4. There's my new point, and then that flops right across here. I also know that if I went 3 out, it would go up 9. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can't, see me counting that off, but there it is. So now I'm going to take and just sketch that in. My expectation is that you would come up with 5 points. I think that that is fair. And I oftentimes, on a quadratic, I just do the next one out, the third one out, because it's easier. For me. Okay, look at number 2. If you can do this on your own, great. Just pause and do it, or fast forward me, whatever is fine. As I look at that, my mother function is a cubic. So my mother function is an x to the third. I know that that in general starts low, ends high. It looks like this. How do I know that? Because I know the mother functions, and that is super important. Okay, now, in general, on the mother, it would start at 0, 0. However, this one is shifting. So how's it going to shift? Well, I think it's going to shift left 4, up 1. So instead of this point here, I'm going to go left 4, 1, 2, 3, 4, and up 1. There is my new point. So I'm going to make a little note up here. I went left. I shifted left 4. And up 1. Now, from there, did it reflect or at all? It did not. So, because I know the cubic function, from that center, if I did 1 and cubed it, I would go over 1 and up 1. But if I went -1, I'd go back 1, down 1, so that looks like this. But it's not a straight line. Remember, we know it's curvy, so if I went 2 out, I know 2 to the third power is 8. So I'm going to count 1, 2, and then go up 8. 1, 2, 3, 4, 5, 7, 8. And also, if I went back to the left 2, 1, 2, and then -2 squared is -8. So down 8. 1, 2, 3, 4, 5, 7, 8. Did I go down far enough? I'm going to count that again. So over 2, down 1, 2, 3, 4, 5, 6, 7, 8. There it is. Now, because I know the basic shape, I know that it should go like that, and it's going to go up forever. So it started low, it ends high. Let's keep going. This next one, all right. What is my mother function on that one? Well, it's got those two lines. What does that mean? Absolute value. What is the shape of an absolute value? Yeah. So my mother function, my MOFU is absolute value of x, which looks like this. Okay, now I'm going to look, and I see that it's going to shift right 2, but there's also a reflection in there, so we got to figure out how that reflects, and then it's going to go up 5. So here's what I see. I'm going to write, so I know it shifts. It goes right 2 and up 5, but in the middle there, right here, I'm going to have a reflection, and it's super important. You have to tell me on the reflection, what axis is that going over? Well, do you see how it's on the outside? Since it's on the outside, that means it's an up and down reflection. So if you could see me, I'm taking my thumb, it's facing up, and then I go over, so the thumb is now facing down. Okay, that said, that means that that is reflecting over the x-axis. So reflection over x-axis. So it's a y movement, it's an up and down movement, that means it's going over the x-axis. So now, because I know it's going to be a V, I'm going to end up, I know it shifts and reflects. I'm going to take, I can just find what my vertex is. So we're going to go right 2 and up 5. So my vertex is at 2, 5. All right, now what technically is happening? My normal one would be, so this is the original, okay? I'm going to take that whole original, I'm going to move it right 2, but then I'm going to flip it down. I'm going to flip it over because of this, oops, I just moved that. Because of that negative sign right there, it's going to flip over. All right, so there it flipped over. So I went right 2, I flipped it down, and now I'm going to take and move it up 1, 2, 3, 4, 5. So that's where it should ultimately end up. And then I look at the end and I say, okay, I know that there's arrows forever. So from the original mother function, I'll draw that back in. The original was right here. That's not exactly perfect, so let's move it down. There it goes. That's your original. Then I moved it right 2. I flipped it over. I reflected it over the x-axis, and then I shifted it up 5. Now, this next one, I see mother function again is, so my MOFU is absolute value of x. So that looks like this. Now, in the actual mother function, it goes up 1, right 1, up 1, right 1, or up 1, left 1, up 1, left 1. Well, this one, we've got several things happening. It's going to go right 3. Then my slope, kind of my slope-ish, it's not necessarily the slope, but it kind of turns out as the slope. It's going to be up 1 over 2 because that's on the outside. So does that get, it actually it's a vertical compression. And so a vertical compression of 1/2 and then plus 4. Now, as we go through this, I have been writing them down, so that's good. So let's start. Remember, if I had my original mother function, that would look kind of like, oh, that is terrible. Hold on, we're going to fix that. I'll be right back. All right, that's better. I just used the line tool. So now that's what the mother function of an absolute value looks like. So it's going up 1, right 1, up 1, right 1. So here's what I know. Now I'm going to take that and I'm going to move it. Okay, so I made another copy and made it red. And so I'm going to move that right 3 And that is great. Now, something is going to happen next. So, do you see that it's still up 1, right 1, up 1, right 1? But that's not what this new slope says, the 1/2. So it's actually going to happen now. Instead of going up 1 over 1, it's actually going to go down so that it's up 1 over 2. Then I grab this side, up 1 over 2. So that was actually a vertical compression. Now, from there, everything is going to then shift up 4. So when I shift it up 4, 1, 2, 3, 4, there is where my final thing ends up. So if I was just drawing that, because I went through and made it with actual lines, the black is my mother function. I move it right 3. And then do you see that actually when I move it up 4, because there's no reflection, really I end up with my vertex at 3, 4. And from there, I know that I can just go up 1 over 2, up 1 over 2, and I could just go up 1 over 2 again and kind of make that. So the one that I made isn't exactly perfect, but there you go. There's how I would draw it. So I have to write down, let's see, it shifts right 3. Then it's a vertical compression or shrink. Compression, shrink, same thing. I like the word compression because that's kind of what's happening. And then I went up 4, and that was the order in it. Now when you're graphing, you technically can go in all sorts of orders and still get the right thing. It's really when you have a reflection over the y-axis that things get messy. So oftentimes I'll just find the vertex and then draw it from there. So that's our first part of moving all of these fun graphs around.